Hello children. So we have finished our trigonometry. We have also done some applications of trigonometry. So today I am starting a new chapter, that is triangles. And I am sure you must have studied about congruent triangles earlier in class 9, 8 I think. But this triangle chapter in class 10, it deals with your similar triangles. Okay, I will tell you what is the similar triangles and what is the difference between a congruent triangle and a similar triangle. So before going to this, we have a theorem in this chapter, which is a very important theorem, and this is known as the Basic Proportionality Theorem, or it is also known as the Thales Theorem. Okay, so I'll try to derive this and prove this theorem, and please be mindful. Okay, so what does it state? If a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, the other two sides are divided in the same ratio. Okay, so earlier, now when you listen to this theorem, पहले तो दिमाग घूम जाएगा, क्या बोल रहे हैं, पता नहीं चल रहा है, but कोई दिक्कत नहीं है. एक line, one line we will go, and then I will explain each and every step and every line, so don't worry about it. So first let me draw the diagram. So A, B, C is a triangle. Then it is written, a line is drawn parallel to one side of the triangle. So DE is the line which is parallel to BC. And this line DE, it intersects the other two sides in distinct points. This line intersects the other two sides AB and AC at distinct points D and E, so that the other two sides are divided in the same ratio. It means we have to prove is AD, let me write, AD by DB. DB is equal to AE by EC. This is what you have to prove. Now, this is to prove given. What is given? Given ABC is a triangle. And what else is given? DE is parallel to BC, and what else is given? And DE intersects, you can say it intersects. Okay, it's not required. It's simply you write DE intersects at BC. I wanted to write that this line intersects AB at D and AC at E. Not required at all. This is sufficient. Now, construction work. See, I have already drawn the construction work over here, but whatever is the dotted lines, these are the construction work. Okay, construction. Join DC and BE, number 1, and draw perpendiculars. Draw perpendicular EN to AD and DM to AE. This is the construction part over. Now I come to proof. How to prove it? So for that we first write, in a triangle ADE, because EN is a perpendicular on AD and DM is a perpendicular on AE. We will be using this perpendicular to find the area ADE. Right. Area ADE. What is it? You know it is half base into height. Half into base into height. Acha. How much is the base? AD. And what is the height? EN. Okay. Name it as equation number 1. Then area. You write DBE. Okay. Area DBE. Again, what is it? It is half into base into height. So you can write it is DBE. So I can write it is half. What is the base? DB. And what is the height for this triangle? The height is EN. Okay. So I multiply EN. This is equation number 2. I want to also find out another area. Let us take DEC area. Area of triangle DEC. Same, half base into height. So in triangle DEC, what is the base? EC. So you write EC. And what is the height? Height is DM. DM. Name it as equation number 3. Okay. Now I will be using equation 1, 2, 3. Okay. Acha. How I will be using? Let us find out. Divide equation 1 with by equation 2. So area ADE by area, you will have DBE. So if you take both the areas, then what do you have? Half, I am writing down, into AD into EN, and this is half DP into EN. So EN gets cancelled, half gets cancelled. So you have AD by DP. Name it as equation number 4. Okay. Now another ratio let me take. Area same ADE by area, I am taking this third one. Okay. So this is equation 1 divided by equation 3. Okay. This one. So area DEC. What will you get? Half into AD into EN by half into EC into EN. This can also be written as, see, this one, why I have got this AD into EN? Because I have taken AD as the base. Now suppose I take AE as the base, the area will be same. If AE is the base, then I can write half into AE into DM by, what is area of DEC? It is half into EC, sorry, this is DM, and this is half, sorry, see, I have made a mistake, and see, it is EC into DM. This is DM. Okay, EC into DM. So DM gets cancelled, half gets cancelled. So what do you get? You get AE by EC. Name it as equation number 4. Okay. Now from sorry, this is 4, so I can name it as equation number 5. Now what can you say about these two triangles, DEB and DEC triangle? See, these two are parallel lines, and you already know that the triangles between two parallel lines and having the same base have equal area. So therefore area of triangle DEB is equal to area of DEC, as reason is as triangles on same base and between same parallel lines. Okay, this is the reason why area of DEB is equal to DEC. Now from equation 4 and 5, from equation 4 and equation 5, what do you get? Area of ADE by area of DBE is equal to area of ADE by area of DEC. Okay, or you can write that what is area of this by this? It is AD by DB, AD by, which implies AD by DB is equal to, what is this? AE by AC. So it is proved. Okay, now check. AD by DB is equal to AE by EC. So what was our initial to proof? AD by DB is equal to AE by AC. So this theorem, it is known as Thales Theorem or the Basic Proportionality Theorem. You will be using this theorem for the whole this triangle chapter. Okay, and what is the conclusion of this theorem? AD by DB is equal to AE by EC. Okay, let us go to the next theorem. Now we go to the second theorem. Now this theorem is just the converse of the Basic Proportionality Theorem. So let me read the theorem. What is it? If a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. Okay, so you have already proved in Basic Proportionality Theorem that a line is dividing a triangle and it is parallel to the third side. You have to prove that AD by DP is equal to AE by EC, but here it is the converse which is given. It is given that AD by DP is equal to AE by EC, and you have to prove that DE is parallel to BC. Okay, so let us first write what is given. Given triangle ABC, and it is also given that DE, and shall I write? Okay, and DE is intersecting AP and AC, okay, such that AD by DB is equal to AE by EC. So in basic proportionality you prove this one, but now this is given. You have to prove that DE is parallel to BC. Okay, to prove, what is to prove? DE is parallel to BC. Okay, now let us start the proof. So before doing this proof, here you have to take an assumption. Okay, what is that assumption? Let it be that let DE is not parallel to BC. If it is not parallel to BC, then there is some line which is parallel to BC, and D, what is that line? Let DE dash is parallel to BC. Okay, and let me write, let DE dash is parallel to BC. Okay, so if this is the case, then as per the basic proportionality theorem, see, DE dash is parallel to BC. So as per the basic proportionality theorem, what can we write? We can write as per basic proportionality theorem. You can write AD by DB is equal to AE dash by E dash E. Name it as equation number 1. Okay, but what is given? AD by DB is equal to, I am writing what? AE by EC. It is given. Okay, so from equation 1 and 2, what can you write? From equation 1 and 2, see, both the LHS are same, so definitely the RHS will be same. So I can write AE dash by E dash C is equal to AE by EC. Okay, Acha. Now here I want to do some manipulation. What is that manipulation? I will want to add. Now let me add 1 to both the sides of the equation. Whatever you do in the left hand side, you have to do the same thing in the right hand side. So what I do, AE dash by E dash C plus 1 is equal to AE by EC plus 1. Fine. Okay. So what is the LCM? E dash C, and I can write AE dash plus E dash C is equal to, this side what is the LCM? EC. So I can write AE plus EC. Okay. What is AE dash plus E dash C? AE dash plus E dash C. It is AC. And what is E dash C? Let it be E dash C is equal to AE plus EC. What is it? It is same AC, and this is your EC. Okay. So what you can say, if AC is equal to AC, then definitely E dash C is equal to EC. see, the numerator are same, so definitely the denominator will be same. So this implies that E dash C is equal to EC. If E dash C is equal to EC, it is possible. This is possible only when E dash and E coincide. Okay, so if it is coinciding, so therefore D E dash is the D E dash is equal to D E. Okay, or E dash is on E. Again I read, E dash is on E. Okay, so I can say that D E is parallel to B C. Okay, so this is proved. Clear? Are you clear here? See, the numerator is equal to the numerator, so definitely the denominator will be equal to the denominator. So it is equal, but if E dash C is equal to EC, it is possible only when an E dash and E are the same point. Okay, so I can write that D E dash is equal to D E, same line, or E dash is on E, it coincides on E. If that is the case, then DE is parallel to BC. Okay, it is proved. Fine. So today we do only these two theorems, and we will start the exercise in my next video. So till then, take care and practice a lot. Practice once again. But stay safe, stay indoors, and follow the online classes to complete your course. Okay, don't go outside.